aside from just writing programs or training models, I got to also improve on things like entrepreneurial skills and presentation skills.
Yeah.
Again, during my time at DAIM, and not just that, including my research skills as well. So I'm a software engineer. I practiced as a software engineer for over 6 years.
How do you see this project evolving or being applied in the future?
It can be applied in so many ways. So first of all, I think one major application for NASA turbofan jet engines is it's just for commercial airlines or commercial flights, like the Airbus, like the Boeing 737. From my research, I got to find out that these NASA turbofan jet engines are used in those applications, right? So one of the some of the successes are basically the fact that I was able to accurately predict remaining useful life of the equipment. I got about up to 96% accuracy in some cases.
Brilliant.
Yeah, for the traditional models.
Yep.
Yeah. So I think that one major thing that I would like to do going forward would be to try to see how I can apply some ensemble models that combine the strengths of the traditional models and the deep learning models as well.
So is it your plan to kind of continue with this research?
Yes.
And how do you intend to do that? Via your entrepreneurship or through a PhD? Or
well, if I get PhD opportunities to pursue to see how I can advance the research, that would be great. But if not, I'm also on my own trying to see how I can do some personal,
okay, just in your own time?
Yeah, in my own spare time.
Superb. That's brilliant.
Yeah.
Good stuff. So you kind of already answered my question on how could your project impact like real world problems, I guess.
Yeah.
And it has big implications for industries.
Yeah.
So can you just expand a little bit more on that? So what if you can create an ensemble model, for example, and it does produce increased accuracies, how will that impact the industry? Not just NASA, but wider industry?
Yeah, so first of all, I talked about the idea of transfer learning.
Mm-hmm.
So the project in itself is not necessarily for NASA turbofan jet engines. I just use NASA turbofan jet engines as a case study.
Right.
So, but the idea is that we want to be able to expand this knowledge to other safety critical systems, as outside of, not just within the aerospace or aviation industry.
No, but for example, in the energy industry, like the oil and gas industry or something.
Yeah, we can apply. There are definitely other safety critical systems we can apply it to. So the idea is that if we are able to predict many useful life for a turbofan jet engine, we should be able to use the same ideology or the same techniques predict many useful life for other kinds of systems, particularly safety critical systems. Because I mean, that's like the safety critical systems are like the major focus for me. Because of course, whenever human life is involved, every human life counts. So
yes,
we want to do our best to reduce the tendency of injuries or fatalities happening in industries. Yeah.
Super. So a bit of a step away from your particular project, but what advice would you give to future MSc students who are working either on similar topics or completely different topics even?
Okay, so one major advice would be to select a project that you're passionate about, because again, for me, one of the reasons why this was easy for me to pursue within with so much passion within that 12 weeks was because I was happy to do it. So if you do something that you are passionate about, you don't need anybody driving you around.
No.
I mean, I had 3 supervisors, 1 from DAIM and 2 from the industry. But then every week was an interesting conversation with them, because I was always going back to research on new things and come up with new ideas to share with them. And and it was pretty smooth. It was a very pretty smooth journey for me because of that. And I also had a lot of support for them. Now, the second advice would be, you might have assumptions, but it's good to test your assumptions with the models. For example, I had expected that deep learning models would outperform the traditional models, but I had a bit of a surprise when the models like the XGBoost model, which is a traditional model, had a much better performance compared to most of the other deep learning models. The only model that came close was the LSTM combined with CNN it came really close to the XG boost, and it helped. It basically performed well across various conditions, but the XG boost model gave the lowest root mean square error basically.
Right.
So
Okay.
yeah, it gave me the best result.
Perfect.
So, yeah.
That's brilliant. So yeah, you've already tackled one of the questions that I missed actually. Any surprising insights? So don't kind of like think you know everything before
Exactly,
you start
you need
working.
to test your hypothesis, and one more thing, I think it's also important to work very closely with supervisors for the project, because I mean I had a lot of support from both from the industry supervisors
Yeah.
and from my DAIM supervisor, because both of the three of them brought their various ideas. The industry people brought their ideas from the industry.
Mhm.
My DAIM supervisor brought his academic ideas, and then I also, based on my previous experience working as a software engineer, I had some software engineering experience too. Combining all of them
Yeah.
together gave me a very good result.
Brilliant. Good stuff. Right. So, two more questions.
Sure.
If you could expand on your project, what additional areas would you explore? So we've already discussed transfer learning,
Yeah.
but where else would you take this?
Well, so I think that again, one major area that I would like to explore would be expanding. Like I said, expanding into other safety critical systems
Mhm.
is one major thing that I would love to do. I haven't really thought about going outside of this, but I believe that it would also be very useful, even outside of safety critical systems. It would also be very useful.
Yeah.
But if you are talking about something else that I would be passionate about researching into or going into outside of just predicting remaining useful life or predicting the reliability of systems, another thing that I think involves safety is the health sector.
Yeah,
Right.
that popped into my mind as well.
Yeah, the health sector
yeah.
is very important, because, like, I mean, imagine if you are able to detect diseases early on. For example, you have people dying of cancer. A lot of them do not detect it early enough.
Yes.
What if we could predict, or what if we could create a system using AI and data science, a system that is able to detect the presence of cancer cells in the human body much earlier than what we have currently
Yeah.
in current applications. So that's one thing that I would be happy to go into, the health sector, particularly cancer applications. Yeah.
Okay, super. So final question. How has working on this project shaped your career and your future aspirations now that we've been moving on to your next steps?
Oh yeah, it has actually helped me a whole lot. Not just working on my project, my time at DAIM helped me a whole lot to hone some specific skills that would definitely help me going forward. So I mean, aside from just writing programs or training models, I got to also improve on things like entrepreneurial skills and presentation skills.
Yeah.
Again, during my time at DAIM, and not just that, including my research skills as well. So I'm a software engineer. I practiced as a software engineer for over 6 years before, or roughly 6 years before I came to pursue a master's degree here.
Yeah.
Right. And as a software engineer, I get to learn every day, research on new technologies. But not just about researching on new technologies. DAIM has also helped me to hone my skills in researching about specific problems that you want to solve. So there's a whole lot to researching than just Googling. Right?
Yeah,
There's a whole
Well
lot to
said.
researching than just Googling or finding answers. So I got to learn a lot of those techniques.
Yeah.
And then also, like I said, presentation skills. We get to present on a specific problem, present how have you solved the problem. So yes, you can write, anybody can write code, anybody can pick up a problem and try to solve it, but how well are you able to sell that problem to an audience? What were you able to do in this project, or what did you achieve in this project? What were your challenges? All of those things. So yeah, I think it's really helped me to hone some of those skills.
Perfect. So what's next?
What's next? Well,
final question. Final question.
Well, for me, I think that right now the major next step for me would be how I can apply some of these learnings in the industry. One of the things I did, one of the things that happened in this project was the data set I used was not necessarily a real world data set.
Okay.
It was a curated data set, a simulated data set, but it was curated by NASA themselves. So what that means is that it very closely resembles real world system, because there was a lot of sensor noise introduced into it that should tell you, okay, this is not just something simulated that doesn't have real world implications.
Yep.
So one of the things I think that is the major next step for me is to be able to, I'm currently actively looking for opportunities to be able to apply my learnings, not just in this project, but all of the learnings I've had in DAIM to a real industry, right? A real industry problem or real industry problems. So from things like data analytics to things like training machine learning models to large language models, right? And large language models are another thing that I probably did not talk about earlier on. So that's one other area that I think would really help if I'm going to expand this project. So we can choose to not just detect anomalies, because one of the places I stopped in this project was I was able to develop a classification system to detect anomalies in the system and then classify them into high risk, medium risk, and low risk zones. But part of what I'm supposed to do in this project, which for the time they didn't permit me to do, is to be able to not just tell you that the system is in the high risk zone or a medium risk zone, to be able to tell you, suggest some specific adjustments you can make to help prolong the lifespan of the system.
Yeah.
And that's one thing that large language models can help you
support with.
So you can probably, just like the way you ask ChatGPT questions, okay, so now you're telling me that the system is about to fail very soon. So what can I do differently? Or ask specific questions, because it should be able to tell you not just the high risk or medium risk. It should be able to tell you some specific areas, some specific sensors in the system that are likely to fail, that will cause that overall failure. So then you can now ask, more interactive, sort of ask, okay, what can I do to adjust this? How about I try this? What do you think of this? And all of that. So I think that's one major thing that I would like to go into next.
Brilliant. Thank you. Well, Nnamdi, thank you very much.
Thank you so much, Lara. Yeah.
Well done.
Thank you.
Super.
Hi, my name is Kevin Pimblett, and I'm the Director of the Centre of Excellence for Data Science, Artificial Intelligence and Modelling, otherwise known as DAIM, here at the University of Hull. We run an MSc conversion course in Artificial Intelligence and Data Science here at the University of Hull. A conversion course takes in students from a wide variety of different backgrounds, not just STEM subjects, but arts and humanities and everything else in between. We upskill them in data science and artificial intelligence, and we do that through a series of bespoke modules, starting with Python programming in the first few weeks of trimester, leading into introductory materials in understanding artificial intelligence and the fundamentals of data science. We've just built a new building that you can see all around me. This is a £4.5 million investment by the University of Hull, and a strategic decision to invest in artificial intelligence and data science for the long term. Here at the University of Hull, we offer the full breadth of artificial intelligence and data science. We have elective options in a range of different subjects, from ethics right through to AI in healthcare, and a lot of others in between as well. We like to have our students on campus for one full day per week. That's from 9 AM right through to 6 PM. What this enables is for our students to manage their own time, so that if they have a job for which they might be going part-time, they can do it for the rest of the week, and therefore they can have that full day on campus learning and doing all the programming that they're required to do. There are a variety of reasons why our students choose the University of Hull as their first choice for an MSc conversion course. Not only do we upskill our students within the areas of AI and data science, but also locally this is one of the best regions in which to study. Here at the University of Hull, we offer the widest variety of different training courses in AI and data science. We also offer bursaries that our students are able to apply for, so if you are female, black, disabled, or from a low socioeconomic background, as might be judged from the higher rate of student loan, and you are a UK citizen, resident, or settled status, then please do consider joining us.